Okay, thank you very much for joining. Today we are coming to our second tutorial for our networks unit. And today's topic, we're going to understand how network, hardware, and software components are connected.
Okay.
Okay, so our indicative content, we're going to look into hardware and what we need to know about the hardware. Communication, so we'll look into the types, which we already looked into yesterday. And software, we'll look into the software required. Type of issue that can occur when we have a physical network assembled. Then we'll look into setup, how this has to be done, and also the requirements. And then we'll look into testing and the security measures that we need for our network. So we already gave a definition of how data communicates and how information is transmitted from a local area network to a wide area network. So as we can see here, we do have a definition for network where it shows that the network simply will consist of 2 or more computers which are linked in order to share resources and also exchange files, which will now allow electronic communication. So a computer on a network might be linked through cable, telephone line, radio wave, satellite, or infrared light beams. So as we know, a network could be a physical or logical network, and this will now define how this will now work. So I have one video which I want to share with you.
If you've got more than enough money coming in each month, feel free to skip this ad. If not,
Hey, what's up guys? Welcome to Certbros. In this video, we're going to be talking about computer networks. So, what is a computer network? Well, first, let's break it down. What is a network? The definition of a network is a group or system of interconnected people or things. So, it would be fair to say a computer network would be a group or system of interconnected computers, right? And that's exactly what it is. A computer network is anything where more than one computer is connected to each other. Traditionally, a computer network would consist of desktop computers, servers, printers, etc. But these days we live in a connected world. We still have desktops, servers, printers, but we now have a vast number of smart devices connected to our networks as well. Most of you will have a mobile phone, maybe a tablet, security cameras, even smart lights are found on networks these days. And the list really does go on and on. So let's take a look at some basic networks and we can see what they look like. First, one that should be familiar to most of you. Here we have a switch, a router, a wireless access point, a desktop, and a phone, all connected to the same network. This is a pretty common home setup. It's worth noting that in most home networks, the switch and wireless access point will be built into the router. Generally speaking, any network in a single area is called a local area network, or LAN. The LAN is usually connected to the outside world using a socket in the wall that your internet service provider has installed. This socket connects you to something called the wide area network, or WAN. The purpose of a WAN is to connect separate local area networks together. The most obvious example of a WAN would be the internet. However, businesses might have private WANs to connect multiple sites together. So now let's look at a more business type network. So we have all of our office computers, and these would usually plug into a wall or floor socket. And these sockets will have cables either running through the floor or the ceiling back to a special room called a wiring closet. This room might also be called a patch room or a server room. In the wiring closet, all of these devices will connect to a stack of switches which are mounted onto racks. Depending on the size of the network, there may be multiple wiring closets which all connect to each other, say for example on different floors. Keep in mind though, this has been simplified to give you a general idea. Lastly, we'll look at another type of network that might not be so obvious. Now I said before, I'm sure you all have smartphones of some sort. Now these phones generally have internet access via 3G, 4G, and even 5G. Well, you can think of these as basically a giant wireless network for your phones. Somewhere close to you there will be a giant tower that allows you to connect and get internet access. The closer you are to these towers, the better the connection is likely to be. So these are just some common network types and really just an introduction to some basic network devices. So the next logical question is, why? Why do we need networks? Well, let's imagine life without networks for a second. If we want to print a document, we would need to directly connect a printer, which is fine. But what if we have multiple computers? We would need multiple directly connected printers, right? Which isn't so fine. The beauty of a network is we can share resources. If I have a file and I want to send it to someone, I can. They can also share the file with everyone else. We can have shared printers that everyone can use. We can even have servers that could store these files for us. Of course, file sharing and printing is just one example, but this could be pretty much anything. And all of this even before we start talking about the internet, which by the way is just a giant network. With the internet, we can search for anything we want. We literally have the world's knowledge at our fingertips. We have email. We can message our friends. We can use hosted computing, telephone calls over the internet, and of course, awesome YouTube content. So networking has changed the world and how we live in it. It's a topic I still get excited about, and there's no shortage of new things to learn. We'll go over a lot of this in more detail as we go. This video is part of our full CCNA course, which can be
Okay, I'll say the video summarize what we covered in yesterday's tutorial. So I hope this concept is clear now, understood. Now, for today, we're going to look into a hardware component. So we mentioned the computer. So in the video, I mentioned smartphone, printers, and all these physical components. So what all these does, all of them does, they are all components which are part of operating system. So they will now have a memory, such as RAM or ROM, and they will now have all the components that we covered in our computer system unit. Then we also have a memory non-resident, which is our RAM, which is for running application or softwares. And then we have bootstrap applications. So our image here defines what bootstrapping looks like. So we can see when we have an initial phase of loading a device such as a CD, what it does, you have a begin with this bootstrap where it's going to upload, where it's going to load the file, and you permanently store in the ROM. Then this will now be located into the operating system, usually in a fixed on a fixed location. Then you now load into the RAM, which will give us instant access to the file. And then what happens is that the loader programmed in the operating system can now be used to load and execute user programs. And you now end with transfer control to start the location of our operating system. So here we do have a simple definition where it says hardware platform and now support the variety of operating system. So we have mentioned the types of operating system in our previous unit, but we can still go through them here, where we show that we have single user. So when it comes to connecting to a network, we can now connect with a single user, and also we can have multiple user system. When it comes to maybe working in a company, in a large organization, they'll have their own closed network and they will now be working with multiple users in one workstation or maybe in different workstation. Then we also have mainframe system, and then network server, which allows us to distribute the information. Then we have real-time system, which they are one or more processed, which they always have to be used to access the system immediately, because it gives you real-time access to it. Then we have distributed systems. What do we mean by distributed? We were just looking into the process of redistributing among the computers in a cluster or in a network. Also, we have embedded systems where they're going to look into specialized system designed to control single piece of equipment, such as maybe automobiles or microwaves and ovens. Then we also have mobile operating system, which are in our smartphones, and we're all familiar with this type of operating system. Now we're going to describe the potential issues when it comes with a computer network. So the issues could be physical or logical. When I say physical, I mean we now assemble our network through cables, routers, and switch, and any accident could now compromise the functionality of our network. Other type of issues could be logical, where we have mistakes done. So when it comes to setting up a network and assigning the IP address, there could be a duplication of them, which will now result in an issue where this machine are registered with the same name, but due to the fact that they have the same name, this cannot work. Then you have also IP address exhaustion. So as we all know, we have got to there is a amount of numbers of this IP address that can be assigned, and we are now currently on IPv6, which gives us a really large amount of IP addresses, which was not possible back in the days due to the fact that the IP numbers, they were limited. Then we have DNS problems. We have single workstation, which are unable to connect to the network for any type of technical issue. Also, they could be unable to connect to the local file or printer share. and so on. Now we're going to explain the steps required to set up and test a simple local area network. So we always need to check the physical connection and see how this is doable. Verify that we can now be able to log onto it. Set up and check the network configuration, and then split out. So what do we mean by this? The command will now split out of numbers, line, and information. So we're basically redistributing the IP address. And then lastly, we're going to re-verify, and we can now ping each computer with a specific IP address. So I found a very nice video which explains us how a network topology works.
What are network topologies? So that's what we're going to talk about in this video. Now, a topology is the layout of how a network communicates with different devices. And there are a couple of different categories of topologies. There's wired and wireless. So we're first going to talk about the most common wired topologies. And the most common wired topology that's used is the star topology. Now, in a star topology, all computers are connected to a central wiring point, such as a hub or a switch. All data on a star network passes through this central point before continuing to its destination. Now, one of the major benefits of this topology is that if one computer failed or if there was a break in the cable, the other computers would not be affected because each computer has their own cable connection. However, a disadvantage of the star topology is that if the central hub or switch fails, then all the computers on that central point would be affected. And this is called a single point of failure. If this happens, the entire network goes down. Another type of topology is called ring. The ring topology is a type of network configuration where each computer is connected to each other in the shape of a closed loop or ring. So every computer on this ring has exactly two neighbors for communication purposes. Each data packet is sent around the ring until it reaches its final destination. Now, this kind of topology is very old and is rarely used today. Now, the advantage of a ring topology is that they are easy to install and easy to troubleshoot. However, the disadvantage would be that if just one of these computers goes down, or if there was a single break in the cable, then all data flow would be disrupted. And the next one is the bus topology. The bus topology is very old technology and, like the ring topology, it's not used today that much. This is the kind of network setup where each of the computers and network devices are connected to a single cable or backbone. And this backbone is a coaxial cable. The computers connect to this cable using special connectors called BNC, which are also known as T connectors. One of the advantages of the bus topology is that it is also fairly cheap and easy to implement. However, a disadvantage of the bus topology is that it requires that the cable be terminated at both ends using terminators. In order for this setup to remain operational, there must not be any open connections, including the ends that attach to the computers. So if a computer is removed or if the terminators are loose or missing, then the cable would be open and then data would bounce back. And this bounce is known as signal reflection. And if this happens, data flow would be disrupted. And there is also the mesh topology. Now, in a mesh topology, each computer on the network is connected to every other computer on the network. So by having so many connections, it handles failure very well. In this illustration, there are 4 computers with 3 connections on each computer, which makes a total of 12 connections for this network. Now, the advantage of a mesh topology is that it creates a high redundancy level, because if one or more connections fail, the computers would still be able to communicate with each other. However, because of the amount of cabling and network cards that have to be used, mesh topologies can be expensive, so they are rarely used on local area networks or LANs. They are mainly used on wide area networks like the Internet. In fact, the Internet is a good example of a mesh topology, because the Internet is made up of numerous routers all over the world that are connected to each other to route data to their intended destination. So even if a few routers go down, the data will get rerouted using a different path to ultimately reach their destination. So the Internet is very redundant because it's using a mesh topology. So now we're going to talk about wireless topologies. So let's start with the infrastructure wireless topology. Now this topology uses a combination of wired and wireless devices. Now this is very similar to a star topology, where you have wired devices such as these computers here physically connected to a switch. And you also have a wireless access point that's also connected by a cable to the same switch. The wireless access point is here so that wireless devices such as laptops, tablets, cell phones, etc. can connect wirelessly to the network. So the wireless access point acts like a bridge between the wireless network and the wired network. Now the infrastructure topology is not limited to a single wireless access point. In fact, you can have multiple wireless access points if you want. It just depends on the needs of the network.
Eve to me is basically freedom. It's a giant open universe where you can do whatever you want.
And the next wireless topology is ad hoc. Ad hoc is a very simple wireless topology, and it's simple because it doesn't rely on any infrastructure such as cables, routers, servers, or wireless access points. All the devices in an ad hoc network wirelessly connect to other devices in a simple peer-to-peer network. They directly connect to each other without using a centralized device, such as a Wi-Fi router or access point. And because they directly access each other without a server or router in between, each device is responsible for its own security and permissions. Ad hocs are useful for setting up a quick wireless network on the fly where devices can share data without the need of an existing wireless network. And the last wireless topology is called a wireless mesh. Wireless mesh topologies are similar to wired mesh topologies, where devices are interconnected with each other, but with the exception that they are wirelessly interconnected. So for example, let's say you wanted to deploy multiple wireless access points all throughout a building so that wireless devices that are in different areas are able to access the internet. So normally you would have a modem that brings in the internet to the building, and then you would also have a switch that's connected to the modem. And then you would connect each wireless access point with a cable to the switch. So by doing it this way, this requires extra cabling, and it would also require extra time running the cables through the building. So this is more expensive and more time-consuming. Now a wireless mesh topology would be similar to this setup, but without the need of these extra cables. In a wireless mesh, each wireless access point will talk to other wireless access points to create a seamless internet connection for wireless devices to connect to. So if this laptop over here wanted to access the internet, it would connect to the nearest wireless access point, and then this access point would relay the connection to the next access point, and then to the next one, and then eventually find its way back to the modem. So no matter which access point that you're connected to, you will still have internet access because all the access points are in constant communication with each other and the modem. And even if one or more access points were to fail, it wouldn't matter because the other access points will reroute the data. So a wireless mesh topology is very redundant because the internet connection is spread out over many wireless access points.
Yeah, I hope the video explain the different type of network topology.
Yes.
If there is no any question for me, then I'll just end the tutorial.
Okay.
Okay, thank you very much, and I'll see you tomorrow.
Okay. Bye.